Hello, and welcome to Lesson 12 in the CrowPanel Pico HMI Display tutorial series. In this lesson, we will explore how to utilize the Bluetooth capabilities of the CrowPanel Pico to communicate with other devices. Let's get a sneak peek and see it in action. When you click the green button on the right screen, the LED on the left screen lights up. When you click the blue button, the LED goes off. The two screens successfully communicate via Bluetooth and control the LEDs of the slave device. Now, let's dive into the Bluetooth functionality of the CrowPanel Pico screen. The Bluetooth functionality of the CrowPanel Pico is provided by the BLE16 module, which integrates Wi-Fi and Bluetooth functionality. For detailed instructions on how to use it, you can refer to the detailed instructions on the Bluetooth function on the NSYNC website. It mainly shows how to use a T commands to configure BLE16 as a BLE device for data communication. In this course, we will control the BLE16 module through the Pico development board to realize the BLE communication function. First, let's understand what is BLE. Bluetooth Low Energy, BLE, or Bluetooth Low Energy, is a wireless communication technology designed for Internet of Things, IoT, devices. It is a power-saving version of the classic Bluetooth protocol, first introduced in Bluetooth version 4.0. The design goal of BLE is to enable communication between wireless devices through low power consumption, which is particularly suitable for devices that are sensitive to energy consumption, such as wearables, smart home devices, and health monitoring devices. In a BLE communication system, devices are usually categorized into host, central, and slave, peripheral. They have different roles and work in different ways. The host is the device that initiates the communication actively and is responsible for scanning and searching for nearby slave devices and deciding which slave to establish a connection with. In practice, a host is usually a device with processing and control capabilities such as a smartphone, tablet, or computer. The host has a higher level of control and is able to initiate and terminate connections with slaves, and can initiate connection requests to multiple slave devices simultaneously. Slave devices are responsible for being discovered by the host and waiting for connection requests. Typical slave devices include smart bracelets, temperature sensors, Bluetooth headsets, etc., which are usually passive and wait for the host to initiate communication. A slave usually connects to only one host device and transmits data upon receiving a request from the host. It may periodically broadcast signals for the host to scan and discover. In the course files, locate the code folder for Lesson 12, which contains the server and client codes. The server code represents the master device, and the client code represents the slave device. There is also a serial port forwarding program. According to the AT instruction of the BLE16, the master needs to determine the MAC address of the slave when connecting to the slave. First, download the serial port forwarding program. This program can use the serial port tool to send a T commands to the BLE16 module of CrowPanel Pico. After the program is downloaded successfully, open the serial port tool, connect the serial port, note that the baud rate should be the same, and check the carriage return line feed. Then send a T plus RST command. Here we can see the MAC address. Remember this address. The host needs to be used later when connecting. Next, look at the client code, which defines a pin for controlling the LED. Here is pin 28. Then set up the soft serial port of BLE16 pin 5 and 4. Then set up the Bluetooth part of BLE16. First set up the Bluetooth name, and then set up the Bluetooth as slave mode. Enter the main program. When BLE16 receives data, first save it. When the received data is a turn off the LED. When the received data is a B, turn on the LED. The program for the slave is as simple as that. Download the program to the slave. Next, we look at the code for the master. Here you can see that the slave contains a SquareLine Studio user interface file. I designed 2 buttons and added events that trigger the Bluetooth message sending action. Since this lesson focuses more on the Bluetooth content, I won't go into detail about the Squareline Studio part here. You can find out how to design a user interface using Squareline Studio in Lesson 6. First, also set up the serial port of the W16, pins 5 and 4 as well. Baud rate is 115,200. Then set up the Bluetooth of the W16, according to the AT command of the BU16. Here it is set up as the master. Then connect the slave. Here you need the slave MAC address obtained earlier. Set up the button event. To open the code of the device, please find the IC file. In the button event, you can see that I modified the action triggered by the button event to modify a flag variable called LAD statuses. When button 1 is pressed, the variable is set to 1. When button 2 is pressed, the variable is set to 2. Then declare the LAD status variable as a global scalar in Y. Next, set up the main program in the loop function by judging the LAD status variable. When the value is 1, send a character through BU16. When the value is 2, send character through BU16. After the execution of both assigned to the value of 3 can be. Okay, start uploading the code. Since the upload process takes some time, I will skip this part. After uploading, I will first reset the slave device because in BW16 Bluetooth, the master device starts the pairing process, so the slave device needs to start first. Now, you can control the LEDs on the master and slave by clicking on the buttons on the master screen. Isn't it very simple? Well, that's the end of this lesson. If you found this video series helpful, please like and subscribe to my channel. Thanks for watching and see you next time.